Okay, so choosing the appropriate test, one sample and two sample procedures. All right, so whenever you're trying, you only know, one sample procedures for means, two sample procedures for means, one sample procedures for proportions and two sample procedures for proportions. There's still the chi-square test, and there's still an inference for regression, and there's still ANOVA. So there's a couple other things you need to know, but at this point, we're only going to work with what you know. So you can ask yourself like three different questions here. So how many samples do you have? So one sample or two sample. Remember your matched pairs included in one sample because the samples are dependent on each other. So it ends up being a one sample procedure. You want to ask yourself, am I estimating something, or do I just want a yes or no question? If you're estimating something, then you are going to have a confidence interval. Then you want a confidence interval. If you just want a yes or no answer, then you just want to do a significance test, because a significance test just tells you, yeah, it's not that value, or it's greater than that value, or less than that value. And then you want to ask yourself, is it a mean or for a proportion? Now, I mean, you don't have to necessarily go in any of these orders. Sometimes I ask myself this one first, but all right, so this one, do teens drive faster on the freeway than the general public? Currently, the general public averages 68 miles on the freeway. A random sample of 200 teens was observed. So they only talked to one sample. They want to know if it's faster, so yes or no, so that's a test. And they're talking about an average here. And then they don't give me the population standard deviation, so it's just a one sample t-test for means. On this one, number 2, it says, are oysters that grow under natural conditions more likely to form a pearl than oysters that are farmed? So they have 4,000 natural oysters and then 3,000 farmed oysters. So there's 2 of them right there, 2 samples. And I want to know if the natural ones are going to have a higher proportion of pearls than the farmed ones. So I'm looking at a proportions. There are 2 of them, so it's a 2 sample, and this is a test. I just want to know, is it are they more likely or not? So yes or no. So 2 samples, each test for proportions. Let me go through. All right, these matched pair ones kids kind of get stuck on. So, well, also let's look at a how many one first, and then we'll look at the matched pair. So here's a how many one. So this one says, how much faster are male swimmers than female swimmers? This might spark a debate in the classroom. So 40 men and 30 women were selected at random to swim in a 100-meter race. So how much faster? So how much? I need to quantify a number there. So if I need a number there, I'm not asking yes or no. I want to create an interval. I have male swimmers and female swimmers, so I have 2 samples, and I want to know how much. So I'm going to obviously be calculating a number. So I'm going to be calculating an average here. So this is a 2 sample t interval for means. All right, here's them under the match pairs. 85 people were observed to see how many seconds they spend brushing their teeth and how many seconds they spend brushing their hair. Estimate the average distance. So you're estimating the average distance, and this is how many here. So there's the interval. It's a average, so there's the means. Now I have 1 sample here. There's only 1 sample of 85 people. We are recording 2 things on them, but these things would be dependent on each other because they're coming from the same group of people. So that's why it's a matched pair. Let's see here. So like this one here, do wives spend more money on non-essentials than their husband? 900 couples were observed. So these couples are going, the husband and wife in a couple is going to be viewed as a matched pair. So they're dependent samples. So it's just 1 sample t-test for means in that one. There's more stuff here, but you just would make sure you want to, if you go to that website, you just want to make sure you unselect these options here because you haven't quite covered, we haven't covered those ones yet. All right, this one right here. So again, you hopefully attempt the problem before you just listen to me, but all right, so in these ones right here, you're trying to, for the first one, we want a confidence interval. So let's see here if I can find it. So the formula for the confidence interval is p hat 1 minus p hat 2 plus or minus z star over the square root of p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2, okay? So back here, I calculated my proportion of flues for the placebo, my proportion of flues with the vitamin C, and then I calculated that combined proportion. I don't need that yet for the confidence interval. It's a 90%, proportions use Z, so it's 1.645, so that eliminates all these other ones. So there's my, so if I take 0.82 minus 0.75, I'm going to have 0.07. There's the critical value, square root. So then there's the p hat 1 times 1 minus that over the sample size plus, this is supposed to be a little 3 here, plus the p hat 2, likewise a 3 there, plus the p hat 2 times 1 minus p hat 2 over 403. All right, so then you do that math there, or sorry, don't do the math, just leave the formula like it is. If you notice here, that is that formula right there, okay? Now the next one is doing a significance test, but with the same data. Now here's the problem with the significance test. With the significance test, if you recall from the notes, you make a statement in the null hypothesis, because we're always assuming the difference is 0, so we're making a statement that the two proportions are equal. So if we think the two proportions are equal, we combine them together to create this combined proportion, okay? So the combined proportion, so if you notice here, it'll be p hat 1 minus p hat 2, that's my statistic, minus the parameter, in this case we're always using 0, and then that standard deviation, I'm not using that p hat 1, p hat 2, I'm using p hat c there, that combined one. So that's what I calculated up here. So the 331 plus the 302 divided by the 405 plus the 403, remember that's a typo, approximately 0.78. So that's what you'll see if you look here in that denominator. There's the p hat c, p hat c, p hat c, p hat c, and then the two different sample sizes. I just closed my thingamabobber. All right, so back over there again, where did it go? So I got my p hat 1 minus my p hat c, or sorry, p hat 1 minus p hat 2 minus 0. I didn't put the minus 0. But then in the denominator, I'm using that p hat c times 1 minus p hat c. There's the p hat c I calculated, plus p hat c minus 1 minus p hat c, but then it's over the respective sample sizes, okay? There's no tricks like that with the mean one. It's just the proportion one, because in the proportion one, you make a statement in the null hypothesis that you think the means are equal. A confidence interval for the mean, so it's x bar 1 minus x bar 2 plus or minus t star. Oh, there's a little trick, I guess, here. Times the square root of s1 squared over n1 plus s2 squared over n2. All right, here's the problem. This little problem here is the t star. If you remember from the notes, we have two methods here. We have a conservative method, or we have an accurate method. The calculator is using that accurate method. When you see a problem like this in the test or on the AP test, there's no way I'm using that accurate method, okay, when I do that confidence interval. I'll do the confidence interval one first. I'm using the conservative method. So the conservative method says that we're taking the smaller of n1 minus 1 or n2 minus 1. So here I've got two sample sizes, 110, 100. So 100 minus 1 will give me 99. That'll be the smaller one. So then this is 99%. There'd be 99% in the middle. So you could either use the small tail over here, so 0.005, or this one up here has an area 0.995 to the left. So inverse t, 0.995. There's my cell degrees of freedom. I get that number right there. So that eliminates A, C, and E. Then if you look here at the difference in the formulas here is that this doesn't have this one squared, so D is the right answer. No real trick here in this one. So when we're looking at the test, it's just a t-test. You've got x bar 1 minus x bar 2. And then here's your formula there. So again, just using the two different means. It's a t, so A and B are out. And then this is the only one that's set up properly in the denominator. Okay, so that is that.